Okay, I think we're live, everybody.
Hello.
Hello. Welcome, welcome, welcome. So, thanks for joining us today. We are here to talk about secure attestations and the in-toto framework. And we'll have our guest, Santiago Torres-Arias, on very shortly. But first, we just wanted to kick it off and say hi. I'm Stacy Potter. I'm a community manager here at Stacklock, and I'm joined by my colleague, Adolfo Garcia Vitilla. You want to introduce yourself?
Hey, yeah, sure. It's nice to see you again, Stacy. I was very sad that last time we didn't get to chat.
Me
But yeah,
too.
welcome everybody to our, monthly security playground where we get together to have some fun chat and trying to hopefully bring some interesting guests and not bore them to death. I'm very excited for today's guest. He's a really good friend, someone who has been doing a lot of good in this space for a good number of years. He comes from a very, very special group of people who have been thinking about this space for a long time. So hopefully we'll learn a lot today.
Yeah, indeed. I was so bummed out to miss the last one, but I got hit with COVID. And it was the first time in the 4 years that it's been around that I finally got it. But it took me out hard. So I appreciate you taking over and doing that live stream solo. So I thank you for that. Um, all right. So, as Adolfo and I both said, we're from Stacklock. We hopefully you've heard about us, but if you haven't, we are passionate about making open source software safer. Our team's background is in creating, maintaining, and scaling open source systems, including Kubernetes and Sigstore. And we're drawing on our expertise in open source and security to really give developers and open source communities better tools to secure their software and manage external dependency risk. So we believe that contributing to open source is a necessary part of our everyday work. And as part of their daily tasks, our company leaders, engineers, and PMs build, maintain, and contribute to open source projects and lead open source initiatives that support upstream communities and advance open source security. So if you want to check us out, there's some links here at the bottom of the screen. You can go to our website, stacklock.com, hit us up on Discord, or subscribe to our YouTube channel. If you're watching us on YouTube, hit that subscribe button. Otherwise, I guess let's talk about it, shall we, Puerco? This is the point in the live stream where we're going to do a little taco talk. So unfortunately, Puerco has been traveling. So he's had a bit of a rough travel day with all the flooding that's been going on in Europe. So he wasn't able to grab a taco anywhere in Vienna. I don't know if there's anywhere that you can grab a taco in Vienna or not.
Probably there's always one that smart Mexican that opens their true taco stores everywhere. Well, sometimes it's
True.
not easy to find, but you can always find one.
Well, I have to
But
tell you, living in upstate New York, it's not so easy. Okay, so I have one place that makes decent Mexican food, like in a 2-hour radius from where I live in upstate New York
oh
right
well.
now. So it's pretty rough. So what I have to do is kind of make my own tacos. So it's a Taco Tuesday for me, really for real here. So this morning I made myself breakfast tacos. That's the picture on the left. And then for lunch, I had some chicken tinga tacos that I grilled up over the weekend. So I had some leftovers left over. So yes, technically, it's a tostada in the front
Okay.
on the right hand side of the picture, but in the back is a soft shell taco. Okay, so I don't know if we want to kind of talk about what classifies a taco. Maybe Puerco, you can give us your definition of a taco, and then we can talk about how I've just bastardized tacos, maybe with my breakfast taco or not. Um, but let's get into it. What are your thoughts on the definition of a taco?
So a taco is like a tortilla with a filling, and you roll it. It's not folded. It's not hard. I mean, you can fry the taco, but it's not hard. No, sorry.
So what about the tacos that are fried as a complete like if I was to stuff my cheese and my meat and my everything inside and then fold it over and dunk it in the fryer. Is that still a taco?
Yeah. I mean, we call those in Mexico flautas. I mean, or taco dorado,
Okay.
which is like crispy taco maybe. And yeah, but it's because you're doing a transformation to the taco. So if you have, I mean, on paper you can have all of the ingredients and they check out to be a taco, but if there was some transformation done to it that you weren't expecting, then you turn it into something different that should probably not be a taco. But I don't know.
Okay. Well, for a gringa like me living in upstate New York, that I have a hard time finding a good taco, I just have to make them. But luckily, I'm from Texas. I lived in Arizona, and then I also lived in the Bay Area in California. And I got exposed to a lot of really good tacos in those three places. So hopefully, I'm not doing too bad of a job impersonating tacos when I
No,
cook them myself.
they seem to be really delicious. Except I don't know. I always have a little bit of an objection about that cheddar kind of cheese that you put on it. Like
It's a
very popular
Mexican
out there.
blend, to be fair, but I agree. I thought I was going to get some flack for the cheese, but that's okay. I can take it. All right.
But well,
So,
the good part is that our guest today is also from where I come from, and he'll be able to weigh in strongly on tacos.
shall we bring him to
And
the
as well
stage
as,
then?
yeah, huh?
Shall we bring him to the stage?
Yeah, probably.
Santiago, welcome to
Hello.
Taco Time.
I was dying to have my thoughts put out. I'm very passionate about tacos, but not structurally speaking.
You don't play with it. It's something you simply don't play with.
I think something that also, I don't think it's very clear to people outside of Mexico is that people also fight about these things inside of Mexico. Like if you're from a different state, you may have different opinions, and it can get very heated.
Okay, I get, yeah.
North versus south.
But I mean, we
east
come
versus
from the
west.
correct part.
All right. Well, I think I can get rid of my impersonating taco pictures, and maybe Santiago, do you want to introduce yourself for our audience so that they know who you are and why we've invited you here?
So I'm a professor at Purdue. I do research on software supply chain security. I've been doing that since I was before I started my PhD. I would even say it's been more than a decade now, which is it's a little bit humbling. I actually didn't think about it before, but it really gets to you. So I do research on software supply chain security. What does this mean? I care about how people produce software and whether they produce it securely. And I care about how people consume software and how do they consume it securely. It seems to be an easy thing, but it has given me a job for more than a decade as well. So it's not as easy.
That's amazing. I remember that probably the first time I became aware of some of the projects you were working on was on maybe KubeCon San Diego, maybe, which by now sounds like ages ago. And by then, it was already mature and you already have software working, and I don't know, incredible.
Yeah. Well, San Diego was a COVID ago, at least, right?
I think it
before
was
COVID.
before the pandemic.
Yeah.
Yeah.
For sure.
Wow.
Was it 2018 or 2016? Gosh, I can't remember, but it was maybe it was like COVID, because I remember going to San Diego. But man, it's all a blur now, right?
Yeah.
It's all a
It
blur.
really did change our perception of time.
For sure.
But it's amazing to see that you have been still, contributing and innovating, and your lab has been producing all of this wonderful research about the space, which is I don't know, it's I'm so thankful that you exist and that you do whatever you do. So it's and it's also very interesting because some of the projects that I work in, that we as a company invest in, also have to do with your day-to-day work. So I don't know. Do you want to kick us off into your interests and the project you work on?
Sure. Can I make a parenthesis and talk about tacos for a second?
Absolutely.
It'll be relevant in a minute. So something that I do think we learn a lot in Mexico is that when you go to a taco place, you develop a lot of skills to know if a taco is good and where did it come from, if this makes sense. I think something about Mexico City having like a taco stand or many taco stands in every block is that there's like a grapevine of people talking to each other and discussing, well, is this a good place? Is this a bad place? Is the meat over there a little bit shady? Do people get sick when they eat meat in certain places? This again connects to what I'll be talking about later, but really the research that I do is how do we develop tools for open source security and supply chain security. So things that I've done before is, for example, take a look at Git, the version control system, and see if you can actually break into it. I've also tried to look at reproducible builds and how could you break into reproducible builds or like bypass reproducible builds. By now we know that XEutils could have bypassed reproducible builds. So we need to do more than that. Sorry, Adolfo, Parco. Maybe I missed the angle. Were you asking about my interests, like besides security, or
no? Just kick it off. Yeah, no, I understand totally what you're saying and how we can connect this to the subjects that we'll be touching on today. Like, I do really want proof that meat is what it is, and that guy really washed his hands before preparing that taco.
Exactly. Yeah. Well, I imagine it applies to other food, but tacos really is the currency of exchange, the culinary currency in Mexico.
For sure.
Well, Santiago, are you able to drive the slides yourself, or would you like me to drive them on your behalf?
How could I do that? Even though I have a PhD in computer science, but I don't know if I can flip the slides.
I got it. I'll just advance them on your behalf. And
thank you.
Yeah, you should be good. So just tell me when you need me to advance the slide. And I'm actually going to just kind of drop off for a minute. And if I have any comments or questions that come in, I would also like to encourage the audience. If you're out there and you want to engage with us and Santiago live, please just enter your comments into the chat and we'll try and get to them. The first one that I would like to highlight, though, is Dan is joining us and says, is a hot dog a taco? Cubril says yes. Gonna have to say no. There's hard no there.
I would say it is a taco, but it is a taco that's doing a very bad job at being a taco. It may excel at other categories, but it's not the best of tacos, or one that I would like show to my mom and say, hey, look at the taco I made.
Indeed. Agree. All right. So I'm going to get out of here. I'll come back on if we have questions, but otherwise I'll turn it over to you.
Okay. So this is what I was talking about, right? So attestations is a concept that's making a little bit of noise now, right? And the idea is, well, in the same way that you do with food, that you want, I don't know, the Department of Health come in and say, hey, this guy did wash his hands, or like they're actually taking care of their kitchen, of their kitchen. You want to know that, right? So before I jump into like what are attestations specifically, can I move on to the next slide? So just as a bit of a background, sorry, I'm a professor, so I tend to like to jump from the very beginning, when we verify software, what we're trying to really answer is, do I believe that this piece of software won't harm me or other people, right? And the way that we do it usually is we tend to talk to like an individual company or an individual repository to tell us that everything is fine. I don't know. Can we go to the next slide? So this is not to like shame Microsoft or anything like that, but I'm more saying you go and download something from Microsoft repository, or you install a driver that has a Microsoft signature, right? It's authenticate, verified, and really what you're going with is Microsoft is telling you, hey, look, trust me, I did my due diligence. I'll do my part, making sure that this is not harmful. Or maybe I'll vet a little bit of the process outside. But it really is like, trust me, bro, this is a good container, right? Attestations are a little bit different in that they allow you to say a little bit more than that. Can we go next? So instead, we move from a model, which is, hey, trust me, bro, I am Microsoft. What you can do is say like richer sort of like information about the software supply chain. You can say, well, yeah, Microsoft says, trust me, bro. But GitHub said, hey, look, it was run on my infrastructure. This was built using GitHub Actions. And by the way, this very cool new tool from Stacklog, Trusty, did a check on this code. And they also say, hey, look, this passes like a reasonable sort of like a smell test or like or bar. It clears or bar, right? And you can slap this into the software, and then you can know a couple of things. You can know a little bit more than what you usually know on the like regular model. What you get is, again, information about each individual actor in the supply chain. What can they say about it, and how much does that mean for you, trust-wise? And this is what I was trying to connect it with the taco metaphor, right? This is the same as having a friend coming by and saying, hey, look, the other day I went to that place. It was not very good. And, well, your friend is attesting that the software coming from that repository is not exactly trustworthy. I don't know, Adolfo, if you have any thoughts about that.
Yeah, I don't know. Sometimes you need a little bit more proof than that.
Exactly.
But yeah, I guess so. What you're saying, comparing just a signature to a system of attestations, is there's a lot of trust that you're putting by just verifying just a plain signature, because there's a lot of things that have to go on top. Because if it's just a signature and you have the keys, there's still the question of identities, and then the question of, okay, if this is vouching for all sorts of good practices behind whatever identities behind this signature, then there's also the question of, okay, if this signature gets compromised, then should I assume that everything in there is still in good shape or not? So by moving the data to attestations, you can have more parties signing in, and also, a better, more, let's say, more commentary as the software gets built.
Yeah, and that is also something that I think is very useful about attestations in general. Is sometimes you may have like disjointed views of what is which software. So to give you an example, in the XEutils case, by the way, I also work with the Internet security team and a bunch of other like open source organizations. So I was a little bit on the front lines ish of the XE debacle. Really, the problem there was that the GitHub repo was actually fine, but the release tarball was not fine. Now, if you were able to say, well, the maintainers attested to this repo, all of the maintainers attested to this repo, but only one maintainer attested to this tarball, then you can have a little bit better of an idea of how that happened. Now, this is not to say that this would have been like bulletproof, stopped any sort of like variant of XEutils, but it can help you know, well, maybe this part of the supply chain doesn't come from this part of the supply chain, and maybe it's because somebody broke in and changed some of the stuff in transit, or it was, I don't know, solar weather flipped a bit somewhere. But then you can really know, right? How does that change your trust equation? And how are you going to address it? Would you not stop trusting it? Or are you going to use this information like moving on? Like, do you say, okay, I'll just make a note about it? And that's another nice thing. It really does allow you to have a richer sort of like determination of trust. It's not just, do I trust this person? Do I not trust this person? And that's about it.
So in this case was all of the commits going into the source code. They had their proper reviews, and they were the version control system was properly secured, but there was something that didn't check out with the release artifact. But was that a problem with the signature, or what? How was that problem found?
You mean with XEUtils?
Yeah. Mm-hmm.
One of the maintainers did go rogue, and he effectively, I remember it ruined the Friday for me because I went down the rabbit hole, like figuring out what the hell was one script doing. But effectively what he did is, or they did, we don't know, they took this checkout of the repo, and usually you do like a git archive or whatever, or like make file target, and you produce a tarball that people install. Now that tarball had a bunch of scripts injected, and it was like 4-line block that started the whole like chaining process. Yes, the backdoor itself was contained on some test files, whatever, but really what set it off was the fact that the scripts to actually build the thing included a check and extracting the malware, injecting it on the binary, and well, it set the whole thing off. If you look at those files, you notice that they're actually they don't come from the repo or even from the tools that should have generated that the scripts. One thing that I point out is you can even tell that the person who was developing this wasn't using Debian, which is the usual like environment that people were using, because the version of AutoConf and that suite of tools was actually way newer. Like it must have been like a way newer operating system where this was developed. And then, without like going to on a tangent, this took me hours to figure out, and a lot of people like me and people more like experts on like reverse engineering and stuff like that found other interesting things. But it would have saved us a lot of time if we had this sort of like paper trail, this sort of chain of attestations that we could use to walk and find the disconnect. Oh wow, here's the point where all of the injection happened. If this makes sense.
I didn't. So I wasn't aware that there were. Like I know about that the vector was there, and that the person from Microsoft that initially found it was they detected a little bit of a performance degradation, and then they started like, oh, there's something fishy here. But I didn't know that they actually had that the bad actor actually had injected something into the release table. That's really interesting. And yeah, so this is exactly a really great example of how that chain of custody was broken, and then we cannot account for that tarball coming from an automated and expected process releasing it.
Yeah, I do want to highlight that again. Maybe we had attestations. This attacker could have figured something out, right? But as things stand, it would have helped at least in detecting or going backwards towards like the right point.
Yeah, so yeah, exactly. So the idea is right now, so the less information we have, we give more shadow for those bad actors to act. And then if we can focus our attention on those, I don't know, having everything bright enough so that we can see what everybody's doing, and just that, focusing on those dark areas that we cannot cover because they need human process or other things, then policing becomes much more easy.
Yeah, so without nerding out a lot, something that I really like about in-toto that I'll talk in a minute is you can think of the supply chain as like a distributed computer, right? And you can imagine these sort of like injection attacks as somebody actually breaking the control flow of a program, if this makes sense. So one way to look at this is, this is a distributed computer. Somebody wrote an exploit that had like a rough gadget of sorts in the supply chain, and everybody ended up hacked. Well, not everybody, but a substantial amount of people that were running that particular version, right? I guess that's also a good time to say hats off to the folks at Microsoft that found this, and to really everybody involved. I think going back to 10 years ago, I do think that the supply chain practices and the awareness and the interest of making things better, not only for companies, but for open source writ large, has vastly improved. I imagine that if in 2019 somebody tried to pull something like this off, I don't think it would have been found that easy, and I don't think people would have reacted as fast.
Yeah, you wouldn't have been expecting it. Well, now it's like, oh, well, you pulled a new dependency, there's something wrong. Quickly, you stop and try to look into it. Yeah, that's exactly amazing. I mean, there's still some open questions on how to prevent rogue actors gaining the confidence of open source projects and injecting themselves into the maintainer core and all of that. But some of those problems are maybe more of human problems and social problems, which are hard to catch, and they're not particular for software. That's my view, at least.
Yeah, I agree with that. I think that I like saying, I don't know where I heard it, is that what you want to do in a computer system is you want to turn security problems into compliance problems. And the way that you do this is by making things very apparent so that you can actually write policy around it. And this connects with this attestation frameworks, because if you have somebody breaking the law, or like breaking the flow by being a bad actor, well, maybe you can ask two people to do it, right? This is usually how the military tends to do these sort of things. If you're shooting a nuclear missile from a submarine, you want two people to turn the key at the same time. And that, in theory, should stop anybody who wakes up in a bad morning and wants to nuke another country from doing it, because now you need to convince the people to collude. In that sense, attestations can actually help you with that. You can say, I want not only one entity to attest for a particular property of the software, I want two entities or two developers. It's the same as like two reviewers on a commit. But now imagine that you can extend this sort of like expectation all throughout the supply chain and say, well, anybody who makes the release tarball needs to have somebody else make the release tarball as well and agree that this is the result of making the release tarball. Or a perfect example of this is like reproducible builds as well. I want two different machines building the same source code, and if they agree with it, it's probably less likely that it has a backdoor.
Yeah. And going back to that metaphor about the two persons turning the key, and I don't know, basically identifying who's supposed to do what, sounds like very novel and something that someone should invent, or did someone already do it, right?
Well, yes, I guess that's really what in-toto is. In-toto, I would say in-toto and Sigstore, which I think they play together very well. And actually, could we bring back the slides here? Yeah. So in-toto, it really is an attestation framework. When I made the first commit back in 2015, this name didn't exist. You maybe had remote attestation as something that some people were working on, but it was really not a sort of like household term. Nowadays, I can say that in-toto is an attestation framework, probably one of the first ones, if not the first one. And the idea is that you can start asking these sort of questions. If we can go to the next slide. Imagine every time somebody walks into this sort of like metaphorical factory in the software supply chain, they use a tool that's enabled with in-toto or in-toto tools themselves, like Witness or like in-toto Run. And what they produce is an attestation of what they did. So with this, you can start generating these attestations that have different predicates. Probably the attestation that everybody knows. It's very popular. It would be the salsa attestation. but you can attest to other things. You can attest to an SPDX SBOM, you can attest to a build log, you can attest to a Git tag, and you use this to build this sort of a chain of trust. Now, in-toto also allows you to then define who is going to do what and how. And that is the whole trick. Now that you have these attestations that collect who did what, you can write a policy that says who can do what and how. Another sort of like piece of the puzzle here is that you can use tools like Sigstore to then know who is who, which tends to be a very, very tricky question. If you combine those two things, then you end up with what I would say, what I hope is a widespread methodology to securing supply chains in the next couple of years.
And yeah, so let me repeat back how I see in-toto, and then correct me if I'm wrong. So to me, it's the best way to describe the desired state of your supply chain process, so that whenever you receive a piece of software, you can verify that all of the actors did what they were supposed to do, and then they actually did it, and they give you unforgeable proof that it was so. Like going back to the taco metaphor, I want to know that the cook washed his hands, that the people actually verified the meat to guarantee that it's not another animal, maybe.
Yeah, so that is kind of it, right? When imagine that you go to a fancy restaurant and you get like what is this restaurant in Coyoacán that was it's actually not Coyoacán, it's in San Angel. It was made by this writer, I think it was Vargas Llosa. I don't know. There's this very fancy restaurant that has like very, very nice tacos. Nice tacos as in like long tablecloth tacos, right?
Oh.
And then they tell you, well, this taco has I don't know, Kobe beef on it and stuff like that. You are paying I don't know how much money for this taco, so they better hand you, if you ask for it, of course, they better hand you proof that this is actually Kobe beef. And I don't know how Kobe beef works actually, but I imagine that they may have a certificate somewhere when they got the beef.
Exactly. I mean, they need to prove that it actually came from Japan, from the region,
Right, and that's kind of what I mean. Imagine that you wanted Kobe software, and there was a way to prove it. And really, in-toto allows you to say, well, I am this person. I made the beef. I'm going to give the next person an attestation that shows that I am the Kobe software person, so they can pass it forward. Then at the end, you end up with a bunch of attestations, and you say, well, is it Kobe beef? Yes. Is this the tequila that comes with it? Is it actually from Tequila Jalisco, or is it somewhere else? Right? Is the tortilla like actually white corn, or is it like yellow corn or something like that? And by using this, you can actually automate these compliance problems, and you can do a lot of interesting security determinations with it.
Yeah, and it's interesting because going back to what you said about turning security into compliance, I think that metaphor also extends really nicely into how at least some of us would like to see some of these things playing out with the regular computer users, like the normal people. If you think about a restaurant, and if you go into the kitchen, you'll see all sorts of certificates about cleanliness and the water that they use and the ingredients and refrigerators working, all of those things. Those things have certificates that can be verified, but you as a consumer, you don't have to really care about those things. They're there if you want to look at them, but it's other systems, in this case, the government or inspectors who are checking it. So in this case, I mean, if we could have something like in-toto working behind the scenes, guaranteeing that software is supposed to be built the way it's expected to be, then I think the future would be super bright.
Yeah, so and that brings me to another Mexican pastime, which is soccer. I think that supply chain security is a little bit like being a goalkeeper in a soccer team. if you're doing a good job, nobody will notice what you're doing. Or if the team is doing a good job, right? If anything, maybe the camera is not even pointed at your side of the goal, right? If things are not going very well, then everybody will be looking your way, and you better be catching some shots and be impressive about it. But that's sort of a dynamic that I think we should strive for. Is if we're playing well as a team, the supply chain, for good or bad, is a team, then nobody should be looking at the Kobe beef certificate, Kobe software certificate, and instead it should be just like automatically verified. There's a lot of systems that use in-toto, and as far as I'm aware, they're transparent to the user. I think most notably, Datadog verifies all of their in-house software using in-toto. And they check things like, did the CI modify the Python code or the Python scripts that came out? Is every single line of code in a commit attested for by a developer in Datadog and things like that? I know GitHub is doing fantastic stuff with attestations as well. It really is starting to become like I like to sell it as the TCP of supply chain. Can we use these attestations and total attestations as a way to, for all of us, exchange packets about who's doing what and how? And if we have enough,
just, maybe skipping a little bit forward, but in fact, the in-toto attestation, because it's so simple and versatile, has become kind of the de facto for supply chain security. But before we go into that, I wanted to ask you, can you give us like a brief overview on how in-toto works, like the layout and the functionalities, the roles and links and all of that?
Sure. So there's really two pieces to it. On one side, you want to be collecting this evidence, these attestations. And the way that it works is pretty much at two levels. If there's a tool that has in-toto integrated on it, or you're developing a tool that has in-toto integrated on it, you effectively just say before and after, take the state of the system, and after take the state of the system. Then this will produce an attestation. If the tool is smart enough, it will tell you which type of attestation it will produce. Say, if you're using something like Tecton Chains, it will produce a provenance statement, and I think it will produce a salsa attestation if that's what you're asking for. I think GitHub Actions has something similar like that. Most CI platforms, I think, have something like that. The other way that you can do it is by really running a tool through an in-toto wrapper. And the way that this works is you do like in-toto run, and then you give it the command as you usually would. And this would wrap the command. This is not I don't think this is the way that it should be done long term. I said, like, I would love everything to be integrated with in-toto libraries. But if you have a tool or something that doesn't have in-toto integration and you really want to start integrating in-toto, you can just use that instead. I've done crazy things with in-toto run, like wrapping Vim or VS Code and capturing editing files and stuff like that. I think at one point we made like a clone of Git using attestations, and you can actually get away with it. But really, these are the two ways. When you capture all of the evidence, then you want to verify this evidence. And the in-toto side of things that does that is this layout file that you were referring to, which effectively, it looks a little bit like this slide, in which you describe who, and who can be like Sigstore identities, or it can be Spiffy Spire identities. It can be code signing certificate from another CA, or you can actually just stick in the public key and say, hey, I generated this key. It's a self-signed cert. We really don't like mandate anything on that regard. You just say, this is the key that should be signing for this attestation. So that's the who. The second question is what. So you can ask questions like, what types of predicates, what types of attestations is each individual step supposed to be doing? And for example, if you're saying, well, I want the salsa attestation from the build system, that's the what. So to put it in like a concrete terms, you can say GitHub Actions is the who, salsa attestations is the what. And then the third thing that you want to ask, that you want to answer is how, which is what are the values inside of this salsa attestation? So for example, is this a hermetic build, or is the GitHub repo that was reported as the input the GitHub repo that it should be? or should it be a particular commit or a particular tag or anything within this realm of like hows. Now, if you do this for all of the steps, then you end up asking yourself who, what, how, and also how do they talk to each other. So these are the lines in the diagram. This allows you to then finally build the whole like supply chain of expectations that then you can, when you get the artifact done, you can verify using the attestations that you got with in-toto verify, and then you can check whether you trust an artifact or not.
So does in-toto verify care about the actual contents of the attestations, the predicates, or that's left out?
It does. It actually, it does. You can answer a lot of the questions there. In practice, we want we made it very pluggable. So we don't want to make like a gigantic library that, for example, checks SBOM licenses or anything like that. But really, what you can do is you can say when you start verifying the licenses in an SBOM, shell out to this command or run this plugin, and this command will tell you whether it was up to snuff or not. A thing that you can do is then embed the command and the input, sort of like the input files, so that you had something like SPDX license check or like a FOSA call or something like that. And you had like all of the licenses that you want to approve on a file, then you can also pass that as part of the sort of the verification. It's a little bit recursive because then you can also go and think of that FOSA check as a supply chain check, if this makes sense. That's another thing that in-toto lets you do, which is you can recurse. You can then take these attestations, pass them to the next person. They verify the attestations up until now. They run their command. They produce an attestation, and then you end up with a like onion attestation that says, at this point, everything was good, and then I did a license check. So look at all of the attestations, my license check, the layout that I verified, and the output that it's correct.
But it's critical. That's why it's the notion of a chain, right? Because for license checks, it may not seem that security related, but when you think about things like, did I pull the correct builder? Do I have the guarantees on its integrity? That's more important, right?
Yeah, and that's a very good example. You can, for example, say you're running your own builder, like your own CI, and you want to check that all of the things that are underneath the actual build are attested for. You can then verify attestations all the way up, and then say, all of this is attested for. This is all up to snuff. Now I'll run the build. Now look at these attestations, their policies. I can get like out of hand very quickly, but you can really do very, very interesting things like that.
Cool. And then now, well, maybe do you want to add anything? Because I have a question around the community process around the attestation types and.
I think I had something, but it left my head. We can come back to it if it comes back.
Yeah, no. So one of the interesting things I've been noticing is that in-toto tracks the kinds of predicates that are attested. So that also means that the project becomes some sort of a registry of those types. Can you tell us a little bit why the project is interested in keeping track of those and what the process is for new predicates to be registered?
Yeah, so a little bit of in-toto lore is that back when Salsa was like starting, a lot of the early discussions happened on in-toto. Like this is like pre-OpenSSF, I think. Yeah. And the idea was, can we start providing recommendations about the like intrinsics inside of it? We're noticing that there's SBOM specifications. They're doing a fantastic job. It's a hard problem. Doing it right is not simple, right? We're starting to see a lot of people asking, what do I put in provenance? This was back in 2017 when we were starting to do like a reproducible builds, tested for reproducible builds. And really what we're trying to provide is the community, not sort of like hey, you should use this, but rather here's the things that we have run into before, somewhat of a standard library of attestation types. And if you want to plug them into your project, this is what they're useful for. And this is probably the knobs that you want to fiddle with. And this is the in-toto guarantee that we will support them in policy, in in sort of like a guidance, in tooling, and things like that. This is not to say that there's no other attestations or that you cannot use other predicates that are not in-toto sort of like recommended. As a matter of fact, the idea is you should be able to define the ones that make sense for you, but you shouldn't be reinventing all of the ones that people have been running into, and maybe a mixed model is what we'll be seeing in the future. I think in practice, a lot of what happens a lot of the times is somebody says, hey, look, I'm thinking of this sort of attestation for, I don't know, third-party security scans. And we're like, hey, guess what? Trivi does it. This other company does it. This other company does it. We're trying to get everybody to talk together. So there's one or two types of attestation predicates for security scans. And now you don't have to be like wasting your time or spending a lot of time thinking about this problem when you really just want to attest what is the security scan on your container images.
Yeah, that makes sense. And also, I don't know if this is covered by the, the registration process, but to quote a friend from GitHub who also works on attestations and Sigstore, and he once mentioned something really important, like attestations without verifications are worthless. So I don't know, do you, as part of registering the predicate types, do you also provide guidance on how to verify them?
Yeah, so the process is actually very interactive in a way. A lot of the times we try to either point people at an attestation or predicate that already does what they want. Sometimes what happens is a predicate may not look obviously like the answer to a question, but it may be. But then we also try to give guidance on how to shape the attestation in such a way that you can achieve certain security properties. It can be very easy to make a mistake when you think of a predicate. And the reason is, for example, one very common example is you shouldn't be making an artifact pass verification if an attestation is missing or if an attestation has a field missing. This is like a fail open, fail close question. Now, if you write the predicate in some ways, you may end up with something that fails open. And well, guidance on that direction may be useful for somebody who's trying to come up with a new attestation. And that's also something that we're trying to help with. Attestations without verification, yes, they're not useful. It's a little bit like the tree falls in the forest and nobody's there to hear it. If you're signing all the stuff out there, but there's no way to hear it or to check that it's actually a tree falling, then who cares, right?
Yeah, exactly. No, it's exactly the same case. Like, and it's all in because it's like, and also like checking inside of the attestation, like that field open and field close is very important because it's kind of what we experience in the world of S1s. Like, yes, I have an S1. Is it empty? I don't know, but it's there. So,
yeah, no, I did some work with a couple of colleagues on just checking S1s in the wild if they had like the minimum elements at least. And some tools were not even generating that. They were like, it has a .s1 in the file name, and that's as far as it goes.
That's about it. Yeah.
Yeah.
All right. So tell me, so what's the best way if I wanted to, let's say that I have my processes in place that I can start generating the required information to attest and maybe create one or two steps that I can verify with a link. What's the best way to start for a small project?
Okay, so there's two sort of unintuitive bits about getting started with in-toto. And I don't think it's inherent to in-toto or attestation frameworks in general, but rather we tend to think that the problem is install the tool and run the tool. But a lot of the times is how do you articulate what is your security policy supply chain wise? Because you may not know what it is, or a lot of the times you don't even know what's happening because you don't have a tool like in-toto to tell you who's doing what. So the way that I recommend people start is take the most understood, simplest part of your system and start attesting to it. You don't need to write a whole end-to-end layout. As a matter of fact, something that's nice about the in-toto is that you can slowly creep it into your system. It's like ratcheting security until you have your supply chain covered. And usually the answer to that is start generating provenance on your builds. Then verify that provenance using an in-toto layout and say a salsa verifier, like in-toto layout that goes to a salsa verifier. And then you can start moving left and right. You can say, is the artifact that I put in the repo the same one that came out of my build system? Now I get another attestation and I check for the two that they're in agreement, right? And then you can go in the other direction. Is a tag release that was released by somebody I trust a tag release that was used by the provenance? And well, now you have 3 steps. This is like your critical path. Then you can start doing more ambitious things. You can start adding, say, legal checks. You can start adding like testing, fuzzing, things like that, and start a testing for those things. A nice thing about in-toto is that, for example, you can ensure that even if your system, I don't know, your system is running static analysis and by some virtue of a race condition or whatever it was, the static analysis wasn't run properly or wasn't run on your build, then you won't have an attestation that matches with the rest of the system and the verification will fail. So again, you can start like kind of like pushing the envelope or the boundaries of the in-toto verified system slowly, one by one.
And they're still available ready for people to download, right?
Mm-hmm. Yeah, there's a family of tools. There's the in-toto Python implementation that it's turning 10 years next year.
Wow.
It's certainly in like a maintenance mode. There is the Go implementation that is going through a little bit of a revamp. If you want to contribute to that, actually, we need a lot of hands on deck there. There's other more sort of like batteries included tools like Witness and Archivista and Judge that are, yeah, you just kind of like set them and forget them for tools that don't have in-toto integrated on it, or for storing these metadata, these attestations for you. And then there's also a lot of tools that are like sort of like in-toto enabled already, and that's probably the easiest way to start. If you have like say a GitLab runner, GitLab CI, there's a YAML knob somewhere. I don't know what the name of it was, but you can just flip that on. We maintain a Jenkins plugin that allows you to spit out attestations. We're actually working on adding Sigstore support for it right now. There's of course all of the fantastic work that GitHub is doing. There's a couple of like static analysis, software composition analysis tools that also come with in-toto capabilities. So you just need to find the right flag and turn it on.
We also have a couple of tools at Zacklog that we can create attestations as the trusty results for the package intelligence if you want to add that. So yeah, it's exciting because it's forming like a really nice ecosystem of all angles on software.
Yeah, and if I can say about Trusty, I really like it that, for example, this is a thing that you can attest for that I don't think you can find a lot of other tools that can attest for something like this, if this makes sense.
Mm-hmm.
So plugging this into your supply chain can also be like a difference maker in terms of like really keeping things up.
Yeah, it's a very, I don't know, we like to think about it as a missing, like the other, not just on the like doing the vulnerability scan against databases and known flaws, but also capturing some more intelligence on the origins of packages and so on. All right, so I don't know, would you, I wanted to ask you, I mean, we're almost at time, but do you want to share some of the cool stuff that you're building in your lab with your students? I mean, I've seen some and it's always very interesting, but.
Well, I think the things that I'm very excited that I can say are kind of like coming. I have a student, a brilliant student. She's working on adding private SBOM exchange. So effectively, can you encrypt parts of an SBOM but still redistribute it? So for example, if you're the compliance officer, you should only be able to look at the licenses, but not the dependencies. If you're the security, sort of like the security lead or release manager, you should be able to look at the whole thing and make a determination. And the idea is that you can take an SPD access bomb, pass it through a magic box, you produce what we call a redactable SBOM. And then depending on who's who, you can only look at it, certain fields. The way that I like to imagine it is, I don't know if you remember those toys back in the day that were like a blue lens and a red lens.
Ah, cool, yeah.
Yeah. And again, we're trying to make it friendly to the whole ecosystem. We're trying to provide this capability without trying to like define a new ISO standard or anything of that nature, and to play with tools that allow you that already work with the standards. And I think this will be very useful for certain like high assurance, super paranoid environments. That's one that I'm very excited about. Another one that I'm excited about is WAC, which is this sort of a supply chain super graph. The way that I'm asking for funds for my lab, we call it the supply chain hypergraph. The idea is that if we take all of these attestations and we stock them in say like a graph database, can then we start figuring things that we cannot figure out about the supply chain. Say, what are the tools that have been affected by a vulnerability just by sort of like revoking an attestation and then just propagating it to the rest of the ecosystem? Or what is the best target of attacks at an ecosystem level of supply chain, for supply chain attacks? Or which maintainers seem to be overburdened by their sort of like criticality of the project and the amount of maintainers that there is? What I want to eventually build is this sort of I don't know if you know this Stanford Internet Observatory that takes a look at like fake news and bots on Twitter.
Mm-hmm.
Now imagine the same for software supply chains. Like, can we take a look at the supply chain? Can we make a report? I think this is very friendly to all of the effort that you guys at StackLog are doing. So.
Yeah, exactly. I mean,
yeah,
I'm not sure how much we can talk about it publicly, but it's certainly related, and we can always have nice conversations to support each other. Yeah, it's very interesting, and this is why I love the work that you do, but because some of these edge questions, because things like, for example, the mistrust on supply chain metadata, that when sometimes companies are afraid of revealing maybe too much on the documents they publish, is a recurrent, trope that companies always bring up. We saw that with Sigstore a lot, for example. And then just having someone, because companies may not have the time to, perfect those technologies, and that's why we need someone like you to take care of those problems, to pave the way for the rest of us.
Yeah, that's what they say in academia. Our job is to like fix problems. There will be problems like 5 years down the line. And certainly it happened with SolarWinds that I started working on in-toto like 5 years before everybody was like, oh my God, this is how bad it can get. So hopefully we can fix a lot of problems that will come up in 2029.
Yeah, awesome. Well, I guess I would thank you on behalf of all of the other nerds working on this.
Well, thank you for this conversation.
Yeah, thanks for coming on. And sorry, I was just in the background. We didn't have a whole lot of questions come in, but yeah, we have like 2 minutes left, and I just wanted to put up some references. So there's a website for in-toto, for Salsa, for the update framework, and for Sigstore here. So everybody go and check out these resources. And if you haven't yet, you can sign up at our meetup page. Check us out on LinkedIn, YouTube, and the website and Discord. So Santiago and Puerco, thank you so much for such a great conversation. This was a lot of fun. And of course, the taco talk was even more fun. So appreciate it. We'll catch you guys on the next one. I think we're aiming for a mid-October date. So we'll let you know and post that soon. Thanks, everybody.
I always enjoyed talking to Santiago. Thank you.
Nice.
Thank you. No, it was a pleasure. Yeah, I hope I'll see you too soon. Maybe KubeCon?
Yeah,
Fingers crossed.
Possibly. All right. Take care, everybody. Bye-bye.
Bye.
Bye.